right? Circuits radiate at high frequency when the dimensions become close towards lambda. So in circuit theory, we use the Ohm's law, and there is only one time variation, no space variation, because the dimensions of the components are very large compared to lambda. So we will take that example. So in circuit theory model or lumped model, the lambda or the operating frequency is hundreds of kilometers, and d dimensions of the components like inductor and capacitor are will be very, very small. This is a very important aspect or assumption for circuit theory. When this assumption is not valid, automatically transmission line effect comes into picture. You see here, the lambda is our scale. This is our lambda, and you see for 50 hertz, the wavelength is 6,000 kilometers. So when a 50 hertz line will become a transmission line, when the length of the line is thousands of kilometers, then 50 hertz can also be considered as a transmission line. Okay. To take this case, a 3 gigahertz RF or microwave signal is to be analyzed only transmission line because the wavelength is 10 centimeters. The dimensions of the components are the traces of the PCB also in the order of 10 centimeters. So you have to use transmission line theory. You cannot use circuit theory. Now, to explain this in detail, you have a sinusoidal waveform. So at this point, it is V0 sin 0. This point, it is V0 sin 90, V0 sin 180, 360. Now consider a circuit domain where F is 30 kilohertz, lambda is 10 kilometer. Automatically, your circuit dimension is very, very small compared to lambda, right? Because lambda is 10 kilometers, the circuit dimension may be the order of centimeters. So medium is a conducting medium, connection in wire, electron is energy packet, power is equal to voltage into current. All these will get satisfied in a circuit because of this basic rule is getting satisfied. Circuit dimension is very small compared to lambda. Now let us take an example. We have a circuit connecting wires, no drop and no delay. The wires between the components are at same potential. Shape and size of wires can be ignored. You see here, node 1, node 2, 2 components, 3 components are connected, and for all practical purpose, the battery node, resistor node, capacitor node, they are all, even though they are connected to the same wire, they are at same potential. The ground wire connected same potential. Even though there is a physical wire with 5 centimeter or 3 centimeter, they are practically at the same potential. Why? Because the dimensions of the wire is very small compared to the operating wavelength. You see here, a clear illustration. This is 3 kilohertz, lambda is 10 kilometer. A resistor is here. The dimension of resistor may be 2 centimeters or 5 centimeter. So you compare 5 centimeter with 10 kilometer. Will there be any phase change? No. There will be no phase change. And as far as the resistor is concerned, all the points of the resistor or all the points of the wire are at the same value of phase.